Okay, welcome back. So let's take a look on the day 6 basic application of Newton's laws. So in today's problems here, we're going to look at two problems about forces and acceleration. So for the first problem here, we know that a student steps on a stationary elevator and then stands on a bathroom scale. The elevator then travels from the top of the building to the bottom, and the student records the reading on a scale as the function of the time. So this will be the graph here. And if we take a look on the graph, so at first the reading of the scale is 80 kilograms. So of course this will be the weight of the student, but then there will be 2 seconds when the reading of the scale dropped to 60 kilograms. So this is due to the acceleration. So as you can see here, we have the elevator and it's just traveling from the top of the building to the bottom. So as the result, there will be an acceleration, right? Because the elevator was stationary. So in this case, this acceleration is going to also balance some of the weight on the scale here. So this will be why we have a drop in the reading. And of course, then the elevator is going to have a constant speed, and then it's going to decelerate and also become stationary when it gets to the bottom. So this will be the entire process. So for the first problem here, you actually don't need to have any calculation. Just by the experiments, you can see that we have like first the elevator is accelerating, right? So it goes from velocity equals 0, and then we have the acceleration, and then it's going to have a constant velocity, and then the velocity is going to decrease so that it's going to stop. So we know that during 4 seconds to 22 seconds, this will be the case when we have the maximum downward velocity, because this will be the constant velocity, and at last the elevator is just going to decelerate and then stop. Okay, so the first one here should be very easy. But for the second one, we are going to do some calculation. So how tall is the building? So to solve the second problem here, we are going to use a few kinematic equations. First of all, we know that the elevator undergoes 2 accelerated motions, which will be the 2 seconds to 4 seconds and the 22 seconds to 24 seconds. So in the case of the accelerating motions, we are going to use the kinematic equations of the displacement equals 1/2 times acceleration and then multiplied by t squared. So because in this case, we either go from 0 initial velocity or we stop at 0 final velocity. So this will be the way to calculate the displacement. And then from 4 seconds to 22 seconds, we are going to use the constant velocity, which will just be the velocity multiplied by the time. Okay, so let's take a look on these two cases. So for the first one here, we need to first figure out the acceleration. So in this case, we can see that the reading of the scale is 80 kilograms, which means we know the mass is going to be 80 kilograms. Okay, but then we have a decrease in the reading, which is worth 20 kilograms. So we can also figure out the force. It's going to be a 20 kilograms multiplied by the gravitational acceleration, which will be 10. And this will be a 200. So we know that the force exerted on this person will be 200 newtons. So now we can figure out the actual acceleration is going to be F divided by the m, which is equal to a 200 divided by the 80, and which is going to be a 2.5 meter per second squared. Of course, this will be a downward velocity, but we know the elevator is actually going downwards. So now we can see that the first case from 2 seconds to 4 seconds. And also keep in mind that this will be the same as the 22 seconds to 24 seconds because we have the symmetry. Okay, so in this process, the displacement is going to be 1/2 times a times the t squared, which is going to be 1/2 times a 2.5 multiplied by 2 squared, and that's going to be a 5 meters. And because we have 2 of these processes, we will have 5 meters both of them. Okay, and then we are going to figure out the middle part. So because the acceleration is 2.5 meter per second squared, and then we also have 2 seconds to accelerate. So we know that the actual velocity is going to be a times the time, which will be 2.5 multiplied by 2 equals 5 meter per second. So now we will see that the actual displacement here in the middle is just 5 multiplied, so we have 4 seconds to 22 seconds will be 18 seconds, and that will be a 90 meters. So in the middle here we will have a 90 meters. So now adding them up together, we are going to have a 90 plus 5 equals 100 meters, and that's also our final answer.